Yeah.
Everyone's up to him.
And then you die. 1, 2, 3, 4, 5, 6. Empty.
All right, favorite candy bar. Stephen began us with the wrong answer, but we'll accept it anyway. Of Almond Joy. Almond Joy only has 2 things that are bad in it: almonds and coconut.
Crunch.
What's so bad about coconut?
Ah,
So disgusting.
coconut is disgusting. Yep, good answer. Good answer. Airheads. We're talking about candy, not classmates.
Okay, yeah. Nerd clusters.
Again, we're talking about candies, not classmates. So nerds? Nerds? Oh, airheads. That's right. Sorry, airheads. Airheads. Okay. All right. What else? Snickers. Classic. Can't go wrong. But Snickers are better when frozen. Yes. Yes. What? Twix is all wrong. Twix is completely wrong. What is their whole advertising campaign, ladies and gentlemen? Left and right. Read the Twix when you're reading the wrapper. They're not left and right. There's upper and lower. They're wrong. There's upper Twix and there's lower Twix. It's not left and right. Not left and right. Okay? So Twix doesn't count right away because of their poor advertising campaign.
I was doing so good, man.
Were you? I'm sorry. Did it kill you out?
Yes.
Dang it. I hate it when that happens. Don't be playing games while we're talking about candy. There's important stuff going on here. Chenza, favorite candy.
Oh my!
You don't know what's the name, so you go to the store and you go, I want that. I don't know what its name candy is. You just find it? All right, well, we'll forgive you this time. Achilles. Twix. Jasmine. Really? There's that many Twix lovers in here? I don't think I've ever met more in a class with one Twix lover. Angel, do you have diarrhea of the mouth?
No.
Then stop. Listen to people for a change. You have 2 ears. You have 1 mouth. You should listen twice as much as you talk.
My bad, friend.
Okay? I know it's your bad. You don't have to apologize for me, but then you go and do it again. Ooh, somebody get to the thing. Quick. Come on. You got 5 seconds to get there. Let's go.
Eric, go.
Let's go. Hurry.
Go, oh my God.
Hurry.
206.
No. Now.
206.620.
206.
0.620.
Oh my God, you're so smart.
So cute.
Mr. Brand.
Oh my God, it's 0.867. It's 1 down. It's 1 down.
You're Alvin.
Hey, hold on one second. Shut up! There's somebody talking to me. I'm sorry. Go ahead.
So aggressive. So passive.
Oh, I will gladly send them to the security desk. Not a problem at all. Please don't return them either.
Bye-bye.
Hey.
Bye-bye.
Kidnapping me.
Okay, thank you.
Bye-bye, Shido. Bye-bye.
You are out of here!
Bro, where are you going?
Oh, be back.
Dude, take all your stuff.
No, I'm coming back.
Okay, are you bringing your mom so I can talk to her about your behavior?
No.
Okay, favorite candies. Pierce, you haven't given us a decent answer all week, so go ahead, give us one. Hershey's. A plain Hershey's chocolate bar.
Hershey's cookies and cream.
Tell me you don't want the almonds in there. Okay, good. Jasmine, you got away easy because I think I got distracted when you were telling me yours. What was yours? No, yours was Twix, wasn't it? Okay, I'll forgive you. It's okay. It's all right. Jack? Okay, can't go wrong with a Reese's peanut butter cup, ladies. You take peanut butter, good. You take chocolate, good. You put them together, you get greatness. Okay?
You know what you should?
What? No, see, they jumped the shark with that one. They jumped the shark with that. It's like M&M's. They jumped the shark. What are you doing, sir? You're fixing it by beating the heck out of it. What? No, I told you about Skittles, right? Did I tell you about my problem with Skittles?
No.
They have no flavor.
Yes, they do.
No, they-
What about lifesavers?
No, when
They
you
don't.
swallow them, they have no flavor at all.
Oh, right, you don't chew.
Yeah,
What about
It's just-
lifesavers?
like gummy lifesavers
The
are
gummies
very
are better,
good.
yeah.
Gummy lifesavers are very good.
They saved my
Gancitos.
sister's
Oh my God,
life
you should try these. You should try these.
No, thanks. That's
no,
right.
please. It's really good Mexican candy.
Okay.
Not a
Next.
Yeah.
Yes, it
I like
is.
dirty nuts.
That's not one candy that like comes with a spoon.
That's just like
That's
that's bread.
If
Oh,
you got
the
candy that you
Bubadinas,
need a
the
spoon,
Bubadinas.
you're eating ice cream. Let's face it.
Oh.
Okay, let's
those are
face
so
it.
much.
I
Those are
don't
like
know what
Snickers.
it's
They're
called.
better when they're frozen.
Or the one that comes.
What about
Klondike.
Yes,
It's like pink.
Klondike bar is not candy though.
Yes, that was.
Those-
That's an ice cream bar, and we're gonna throw that in with
There's
the
like
ice
a
cream.
lot.
Those are so good.
Nothing wrong with Klondike bars though. No,
Until you're eating.
I was just
wait. Oh yeah, Klondike bars. Yeah, I was thinking for a second there, those crappy peppermint patties.
Ew.
The ones that they're peppermint that's covered in chocolate.
York.
The York mints, yeah, those are terrible.
I
You
have
like
one.
those?
Yeah, those are.
Really? I didn't even know they still made those. So, all right, what else? What else we got?
Mm.
Faith, you're awfully quiet back there.
Kit Kat.
Peanut M&Ms.
Oh, that's so good.
That is the
That's
best.
valid.
That is the best. But again, M&Ms have jumped the shark too. When you start to put toffee and brownies and stuff like that in an M&M, forget it. Forget it. Peanut M&Ms are good though. Don't swallow those either. You gotta chew those. I learned that almost the hard way. What else? What else? What else?
Sour Patch Kids.
Ew, no.
So good. The watermelon.
Oh my goodness!
Bro.
That is the one flavor that should be taken out of Starburst as well. It's the watermelon, the pink, no, strawberry, the pink one. Watermelon and strawberry. Don't try to cover it up by making it seem like it's fruit, ladies and
What
gentlemen.
about
It's candy. Don't try to fake it.
Kit Kat?
Kit Kat,
The
terrible.
mint Kit Kats.
What?
Oh,
Terrible.
The mint ones are so good.
No.
Oh, the Ferrero Rocher
What about
hazelnut
the Bueno?
chocolates.
So you don't know any either. Okay, we got it. What?
They're so good.
Bueno?
Kinder,
Bueno?
Kinder Bueno.
I don't
Yes.
speak French, so this doesn't help me.
What do you mean either?
Then why are you talking in another language?
It's the name.
Oh, okay.
Look, right here, these things. Those are so good.
Oh.
They're so good.
All right, ladies. First of all, there should be two categories. There should be candy and there should be candy bars.
You said
Okay.
candy bars.
I understand, but I'm just saying those would fall under candy bars.
Oh, yeah.
Things like the Sour Patch Kids and the Swedish Fish, those fall under candy, which is good, ladies and gentlemen. They said they were keeping you.
Well, he did it.
They did. He said he was keeping you. Are you sure you're supposed to be
Bye
back?
bye. Bye bye.
Bye-bye.
You don't want
Really? I find that impossible to believe.
He changed his shoes.
No,
Impossible to believe.
Where you?
So anyway, things like Jolly Ranchers, things like Suckers, things like Swedish Fish,
Candy
those should be
corn.
one category.
why.
Okay?
Got me a-
Swedish Fish are the best, though, ladies and gentlemen. Swedish Fish are the best candy there
No,
is.
candy corn.
Okay? Now, when I was a kid, Swedish Fish cost a penny at the concession stand after a baseball game, and I'd go over there and I'd drop a $5 bill and make them count out 500 for me.
Like
They loved
individual?
me. Individual. They sold a single Swedish Fish for a penny.
Okay, that's just weird. I'm sorry.
It was a concession stand. Second greatest candy when I was a kid, the flying saucers.
Those are nasty.
Flying saucers. You don't like the flying saucers or the Swedish Fish?
Flying saucers and they're disgusting.
Yeah, they're just like two little communion wafers put together, and then they have little dots of sugar in the center of them. Wax bottles, also good, ladies and gentlemen.
Okay.
Wax bottles, you cut out the middleman, you rip off the top, and you drink the sugar as liquid. That's great. That's great. Okay.
Oh.
Candy bars, you gotta go with
Yeah, I
Snickers.
like that great.
You gotta go with Reese's, and of course, you have to go with Nestle's Crunch.
No, M&M's.
That's not a candy bar. Oh, yeah.
Oh, candy bars. Oh.
Eric, next week you'll be able to catch up to us and get to where we were today. Unfortunately, you'll be a week behind again. All right, ladies and gentlemen. So today we got a bunch of things to do, including finishing up this that we started yesterday. So take out that packet, ladies and gentlemen, so that we can finish this up. So take out your how much is a mole packet that we started yesterday. All right. All right. We can now, ladies and gentlemen, go to the second page, the third page, sorry. And in here, our mass was 206.620.
Oh, we can't see.
I'm working on it. I am. There you go. The time was 9:15 and 30 seconds. That's why we had to stop, ladies and gentlemen. Okay? So, first question. What was the mass? I hope you got your calculators, ladies and gentlemen. Hope you got your calculators. So, for the mass of water that evaporated, Angel, you lied to me already.
Oh, my bad.
No, my bad. Stop it. All right. All right, ladies and gentlemen. So the mass of water that evaporated, we're going to take 216.079 minus 206.620. When we subtract these two, what do we get, ladies and gentlemen? 459. What's the unit? Grams of water. So that's how much evaporated from yesterday, ladies and gentlemen. Okay? So how many moles of water evaporated? So what are we going to convert? From what to what?
Mass to mole.
Okay? We're going to go from grams to moles. So if we're going from grams to moles, what do we need, ladies and gentlemen?
The formula. Unit. Mass.
Okay, we need the formula mass, not the FU. This is the FM. Get with the program. We need the formula mass. So for water, 2 times 1.01 plus 16. So that is 18.02, ladies and gentlemen. So we're going to take our 9.459 grams times 1 mole over 18.02 grams. Grams and grams will cancel. We will be left with moles, ladies and gentlemen. So that is about a half a mole. Somebody tell me it's a little bit more than a half. Somebody with a calculator? 9 divided by 18 would be 1/2. 9.4 is bigger than 9, so that's going to be more than a half. Well, you're wrong. Give me a number. What's the number, Stephen?
0.5249.
That's more than a half. Ha! 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 Come on, stay with the program. What is it? I'm sorry. Go ahead.
0.5249.
It's terrible. I'm always right, ladies and gentlemen. 0.529. Give me one more sig fig. 5429. Thank you.
No, in between the 2 and the 9.
Okay.
So 5, 2, 4.
I didn't miss it. Stephen didn't say it loud enough.
I missed it.
Teachers never make mistakes.
0.5249.
Yes.
What's the unit?
Grams.
No, the unit is not grams. Come on.
Oh.
The unit is moles of what? Moles of water. Good, 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 good. All right, ladies and gentlemen. So now, let's keep moving. Okay? So for number 3, getting rid of the stuff I have. All right, how many moles did we have? 0.529 6.0249, correct? All right, Not wants to know how many molecules. So how do we get to molecules from moles? Goes where? 6.02 times 10 to the 23rd. What is the actual unit? Come on, 6.02 times 10 to the 23rd. What?
I mean, the unit is not.
The unit is molecules. Over what? 1 mole. Okay? We're going to particles. We're going to pieces. The pieces happen to be molecules here, correct? Okay. So take 0.5249 times 6.02 times 10 to the 23rd. Somebody tell me what we get.
How many 60s?
Well, we're carrying 4 right now. Let's be consistent.
3.160. 3.160 times 10 to the 23rd power.
10 to the 23rd power.
Yeah.
Okay, what's the unit?
Molecule.
Molecules of water. And water would actually be a molecule, ladies and gentlemen. That smallest particle is actually a molecule. So how much time in seconds elapsed between the two readings? 86,400 what?
Seconds.
How the heck did you get that?
My calculator.
Okay, you can't on a test say my calculator told me this.
I'm multiplying 60 times 60 times 24.
Why 60 times 60 times 24?
60 seconds in a minute, 60 minutes in an hour, 24 hours in a day.
So how much time has elapsed since we did the lab yesterday?
Exactly a day.
Exactly 1 day. So what's the first conversion we would use to get to seconds then?
Hours.
Hours. How many hours in a day? Hours on top, days on top. Which one? 24 hours on top, 1 day on the bottom. All right, what next?
Minutes to hours.
Where goes where?
Minutes on top.
How many?
60.
Okay, what goes next?
Seconds.
How many?
60 seconds.
Where?
Up.
Now, Josh, I agree with what you said, but you need to show me how we get from one unit to another, and you can't just put, well, because my calculator said. Okay? So, what was our actual number here, Josh? 86,400 seconds. Questions, ladies and gentlemen, on why we did any of those things in that calculation?
What's the purpose of knowing how many seconds?
Well, because of the next question, which is how many molecules of water evaporate in 1 second? Okay. So, for number 5, ladies and gentlemen, we need the last 2 answers. 3.160 times 10 to the 23rd molecules have done what? What does that number represent? The amount of water that has evaporated in molecules in 1 day. So now, if we want to know how many have evaporated in 1 second, what do we do with this? We divided by how much time it was since we took the last reading, which in seconds is 86,400. So now I need 3.160 times 10 to the 23rd divided by 86,400. What's our unit going to be? More than that.
Per second.
Molecules per second. Now, how many sig figs? What's our number to 4 sig figs? Somebody. Do the math here. 3.160 times 10 to the 23rd divided by 86,400. But again, 86,400. We are not doing sig figs on that. Why?
So it's 4 6.
You're right. This does have 3 sig figs, Shenza.
Yeah.
But in reality, if you go back up and look at the digits that's in your time, they're like 6 sig figs there. Hours, minutes, seconds, right? So that's not going to limit our sig figs. So what do we get? Somebody.
3.657
Times 10 to the 18th. So just so we're clear, ladies and gentlemen. Thousands, millions, billions, trillions. Every second, 3,657,000 trillion molecules of water evaporate. Every second. Into the atmosphere. Into the air. And this is assuming, ladies and gentlemen, that none of the water that's in the air does what? None of the water that's in the air does what? Recondenses and lands back in there. Well, if you think about it, if that many molecules of water evaporated every second, shouldn't every lake, river, and stream on the planet be dry? If water only evaporated? But it's not. Why? Because water vapor that's in the air will recondense and refill part of the oceans, lakes, rivers, and streams. It isn't a one-way cycle, ladies and gentlemen. Questions? All right, our last question. I asked you to take a guess. What?
100 years.
100 years. You figured it out and you decided to give me the answer right away, huh? Well, let's see how close he is to being right. Okay? Our question said, you take 1 mole full of pennies, ladies and gentlemen, and distribute them to all 7 billion people on Earth. Now, somebody got mad at me last hour. Why? Because there's now 8 billion people on Earth. You want to switch it to 8 billion? We can make it 8 billion. Okay, it's our problem. We can do what we want. So we are starting out with 6.02 times 10 to the 23rd pennies. And we are dividing it by 8 times 10 to the 9th people. Okay? So this will get us from pennies into pennies per person. This is your share of the money. Okay? But I'm not going to stop there. Now, we want our share of the money in what unit? Dollars. So what's the relationship between dollars and pennies? So what goes on top? What goes on the bottom? 100 pennies does not go on top. $1 goes on top, 100 pennies goes on the bottom. Otherwise, pennies are not canceling out. Please keep track of your units here. Okay? Then what's the next conversion factor we're going to need?
Year.
Really? How are we going to use year? Well, $10,000 is per what? Minute. And that's how much you spend, correct? So ultimately, we want a unit of what? What unit do we ultimately want to get to? We want a unit of time, okay? We want a unit of time. So this is a relationship between money and time. $10,000 per minute. Normally, time and money do not get related. This does. Where does money go? Where does the $10,000 per minute go? Look at your units. Where would the $10,000 go? On the bottom. So what goes on the top? 1 minute. Now, ultimately, what do we want our unit of time in? Okay, so let's work from minutes toward years. What would be next? 16, what?
60.
Minutes in what? In 1 hour. So where does minutes go? 60 minutes on the bottom. 1 hour on top, or yes, 1 hour on top. What next? 24 hours. Where do you want that? What do you want on the top? 1 day. Then what do we want next?
365 days.
365 days.
Where do we want that? 365 days. Now, technically, ladies and gentlemen, if you wanted to get a little bit more precise, what could we use instead of 365 days? Because we will have one next year. If you wanted to, you could do 365.25. Well, because isn't there a leap year every 4 years?
Yeah.
Unless, of course, there's 500 years and then we don't do a leap year, but we just had that in 2000. So in reality, ladies and gentlemen, if this comes out to just a few years, does it matter? Not really, but if it does come out to a lot, maybe we should have used 365.25. You could justify either one here. Okay, we'll leave it at this, but you could justify it. So we are now in the unit of years. All right, somebody do the math correctly. 6.02 times 10 to the 23rd. Do I multiply it by anything else on the top?
Nope.
It's all ones. Now, divided by, and I would put all of this in parentheses. 8 EE to the 9th times 100 times 10,000 times 60 times 24 times 365. Close the parentheses and tell me what we get. And hit equals after you close the parenthesis.
143.169.
What's the unit?
Year.
Years. So, anybody else get the same number just so that we're
Yeah. we all know.
good? We're good? Could you spend the money, ladies and gentlemen?
No.
That tells you how big the mole is. If you take a mole full of pennies and divide it up over every man, woman, and child, and ask them to spend the money at $10,000 per minute. So 5-minute passing period, you need to spend $50,000. 71-minute class, you need to spend $710,000 during that class. Okay? What? You're going to buy a house? You're going to buy a house?
Yeah.
You're going to have somebody build you a house, or you're going to buy one that's already built?
It's already built.
You're going to buy one that's already built?
Yeah.
Okay? What would you do with the money, Phoebe? First thing you would get?
I don't know.
You go to the mall?
Oh, well.
Here's one problem when you go to the mall.
Buy at the whole store.
You're gonna fuck.
Buy them all.
No.
Buy them all.
Who's working? Why is Angel working?
We work at Target.
You think he's going to be working after he has this much money?
I mean,
Sure.
he's like the #1 worker.
He could. Okay? He is. How many of you would no longer work if you had this kind of money? You're lying if your hand's not up right now.
No, I'm not.
But the problem is,
Yeah, Bill.
Price per
please think about this for a minute. What happens if everybody has this amount of money? Money becomes worthless.
Taxes.
Right.
Would you work if you had this much money? No.
It'd be better for everyone.
Okay? You can't spend your money in 143 years spending it $10,000 a minute. If we up that to $100,000 a minute, you still got 14 years. The question is, who's going to be working when you go to McDonald's for you to get a Big Mac from?
Me.
Nobody.
From Cheeto.
Money would actually become worthless, ladies and gentlemen.
But what do you buy?
I couldn't buy anything. Who's going to be working at the store to go buy it from?
Just go in the
Who's
kitchen.
going to build a new car for you if everybody has this much money?
Oh, Walker.
Who's going to be working if everybody has this much money? Nobody.
You could.
So you know what? Your money becomes worthless.
What?
Money buys happiness.
Right. For you it does, Eric. Okay? For you it does. Okay, questions, ladies and gentlemen. Okay. Get to this slide, ladies and gentlemen. Finding empirical and molecular formulas in your notes. Let's go.
Yeah, Lane was correct.
It's free. Free trial.
But what if you
I'll take for the.
Okay.
Do you want the flip?
So the first thing we did, ladies and gentlemen, was showed you how to get into and out of the mole. And the reason we're doing that, ladies and gentlemen, is so that we can then take and we can work on. Hang on. Let me get this out of the way. One of the things that happens, ladies and gentlemen, is when you are talking about the formula of a compound. Okay, gentlemen, we can just separate you. Okay? You're bad. Yes, I know it's your bad. Okay? Quit talking.
Okay. Stop talking to them. Stop talking to them.
Yeah, there's a seat you can take way back there. What, you want me to go back and open up the tab that he just closed down so I can see
He
what
closed
goes
it.
down?
It was Delta Matt.
Whatever. Okay? All right. So, there are different kinds of formulas, ladies and gentlemen, for compounds. There is what is called an empirical formula, there is a molecular formula, and there is even what is called a structural formula, ladies and gentlemen. An empirical formula is a formula written in lowest terms. What kind of formulas are always written in lowest terms? Ionic. Ionic compounds are always written in lowest terms. Always. 100% of the time. If you write an ionic compound, you have to lower it down into lowest terms. So what kind of compounds are not written in lowest terms? Covalent. Covalent or not. Some of them can be. It is possible that the covalent compound, carbon dioxide, CO2, that is written in lowest terms. You cannot reduce that. Okay? Dinitrogen tetraoxide, N2O4. That is not written in lowest terms. So covalent compounds may or may not be written in lowest terms. It is possible that they could be either way. They do not have to be. Ionic always have to be. So an empirical formula is a formula that is written in lowest terms. Okay? It shows the ratio of the elements in a compound. What's the ratio of elements in water? 2 hydrogen, 1 oxygen. Does it ever change? No. What's the mass of the 2 hydrogens? 2.02. What's the mass of the oxygen? So in reality, there is not only a ratio of the elements in the compound, 2 hydrogens to 1 oxygen, there is also a ratio of the what in a compound? The masses in a compound. The masses in a compound. Okay? So the ratio is a formula, is a molar ratio of the elements in a compound. Okay? So in an individual atom, or let me rephrase that. In the individual molecule of water, there are 2 atoms of hydrogen and how many atoms of oxygen? 1. Okay? Now, if you had 10 molecules of water, 10, how many hydrogens would you have?
20.
20. How many oxygens would you have?
10.
It's still a what to what ratio? 2 to 1. Now, what if you had a mole of water?
Still
2 what?
2.
2 what?
42.
2 what in there?
H2O.
There's 2 H2Os in 1 mole of water?
No.
So what is there 2 of? 2 what still? What's the 2 part?
H.
Hydrogen, right?
Oh, 2 oxygen.
2, how much oxygen?
4.
1.
Slow down.
1.
2 hydrogens to how many oxygens?
1.
1. Okay. I know. I'm making you think about this, and thinking is not always our strong suit without seeing things. I know. What is 1 molecule of water made up of?
2H.
2 what of H? 2 what of them? What is the unit? No, hydrogen is the element. What is the unit for hydrogens in a molecule of water? 2 what? 2 atoms of hydrogen, correct? What is the unit for oxygen and how many? 1 atom of oxygen, correct? Okay. If we had 10 molecules of water, what would we have? 20 what? 20 atoms of hydrogen, and which is still what? Good. Does that ever change?
No.
So if I have 1 mole of H2O molecules, what have I got?
You got 12 forming.
Nope, I don't want to go to math. Don't. We're on a theme here. Let's not ruin that thing. What do I got?
You got 2 mole atom of H. And 1 mole oxygen.
Right? Yes? No? Maybe so?
Yes.
You're sure about that?
Sure, whatever.
How can 1 mole of something contain 3 moles of something else? Well, he's absolutely right. Okay, let me ask you this. If you had 12 Big Macs, oh, I know. I'm hungry. How many pieces of bun would you have?
24.
Apparently no one in here knows what a Big Mac
36.
is.
36.
By the way, ladies and gentlemen, a Big Mac, 2 all beef patty, special sauce, lettuce, cheese, pickles, onions on a sesame seed bun. Advertising works, because when I was a kid, McDonald's would run a special where if you'd walk in and sing that song, you got a free Big Mac with your purchase. 2 all beef patty, special sauce, lettuce, cheese, pickles, onions on a sesame seed bun. How many buns?
3.
Again, we're talking about a dozen Big Macs. How many buns? 36. How many burgers? Well, there's one on the top, one on the bottom, one in the middle, right?
24.
And we have 12 Big Macs, correct?
Oh,
Wait.
well.
So if we have 12 Big Macs, we have how many buns?
24.
You confusing me. You said burgers.
Yeah, I had two burgers. I have
Slow down! Because this is going to get confusing if we don't slow down and listen. So let's start. You have 12 Big Mac sandwiches.
Yes.
How many pieces of bun do you have?
36.
How many burgers do you have? So how can 12 sandwiches contain 36 and 24 of something? Because of the makeup of it. Because that one sandwich is made up of 3 buns and 2 burgers, correct?
What cheese?
Yeah, cheap people at McDonald's. 1 cheese. 1 cheese. Let's not get into it.
I put 2.
Point being, ladies and gentlemen, a molecule is different from the atoms that make it up. Okay? A molecule is different, just like a Big Mac is different from the buns and the burgers that make it up. If you have 10 cars, how many tires will you have on those 10 cars? 40. Why? Because tires are part of the car, and 4 of them go into making up the 1 car, correct?
Yeah.
So when you're talking about pieces of something, there can be more pieces of something than there are the original thing. There are 4 tires in a car. There are 2 doors, or 4, let's make it a 2-door vehicle. There are 2 doors on every car. So you would have 20 doors on 10 cars. More doors than the car because the doors are part of it. The hydrogen atoms and the oxygen atoms are part of this molecule. So if I have 1 mole of this molecule, I have 2 moles of the hydrogen atoms and 1 mole of the oxygen atoms. Questions?
No question.
Okay, 2 moles of hydrogen atoms. What would its mass be? What would the mass of 2 moles of hydrogen atoms be? Come on, guys. Not a difficult question. 2 moles of hydrogen atoms, what would its mass be?
we actually give you
2.02 grams. Right? What would it be for oxygen? 16.0 grams, correct? Where am I getting those from?
The periodic table.
Good.
Abundance.
1 mole of water. What would the mass be?
18.02.
The parts still, that's the world's worst arrow, make up the whole thing. That is a terrible arrow. I'll be the first to admit that.
Horrible.
Horrible.
Completely. That's not even an error.
There. That's better. Okay? So the parts make up the whole thing. Okay? So these 2 moles of hydrogen atoms and this 1 mole of oxygen atoms make up this 1 mole of water molecules. The 2 grams plus the 16 grams make up the 18.02 grams over here, correct?
Sure.
Good. Good. Good, 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 good. Okay. Now, if there is a second type of formula, ladies and gentlemen, and it is called a molecular formula. A molecular formula is the formula of a molecule. Okay? Now, again, we can't technically say this, but this would be very similar to a what formula?
Top form.
A formula unit. A formula unit. Because if it's not a molecule, it might be a formula unit, correct? Okay. It is not necessarily in lowest terms. By the way, if it is a formula unit, it has to be an empirical formula. Why?
Because it's ionic.
Because it's ionic. Ionic has to be in lowest terms. Okay? So you cannot have a formula unit for a molecular formula. Make sense? Good. Could be in lowest terms, but does not have to be. Could be in lowest terms, but does not have to be. Carbon monoxide, lowest terms. 1 carbon, 1 oxygen. C2H8 or C2H6, dicarbon hexahydride, not in lowest terms. Okay? And then there's what is called a structural formula, ladies and gentlemen. Now, we will not get into very many structural formulas, because if you're going to get into structural formulas, you're going to get into organic chemistry, and this is not a course in organic chemistry. Organic chemistry is compounds that contain what element? What is the element of life? Carbon. Now, hydrogen is part of it, and oxygen, because water is needed for life too. But all living things on this planet are based on one element alone, and that is carbon. They all have carbon in them. Okay? They all have carbon in them. Okay? So, a structural formula is a formula that shows the ratio of all elements. Okay? It also shows how the compound is put together. Its shape. Okay? It could be in lowest terms, but it doesn't have to be. So it is like a molecular formula. Okay? But here's the thing. Two organic compounds can have exactly the same formula, but different shapes, which makes them different compounds. Well, that's why we're not getting into them. Two organic compounds can have exactly the same formula and be two different compounds. We're not getting into those. Okay? All right, ladies and gentlemen. So if a sample contains 12 grams of calcium and 23 grams of chlorine, we're going to find its empirical formula. Why does this have to be empirical?
It has to be lowest terms.
Why does it have to be ionic?
Because you have Ca.
What about Ca?
That's a metal.
It's a metal. If you have a metal in your compound, it has to be an ionic compound, correct? The only kind of formulas an ionic compound will ever form are empirical. Always in lowest terms. Never any other way for an ionic compound. So what we are going to do is something you already know how to do. We are going to take these out of grams and get them into moles. When in doubt, in chemistry, take what you're given and get it into moles. If you have no idea what to do with the problem, take what you're given and get it into moles. So how do we get 12 grams of calcium into moles? No, it isn't a good question. It's one you know the answer to, and you should be easily able to give it to me. How do we get 12 grams of calcium into 1 mole? What do we use? No, we do not use 6.02. I'm not trying to get 2 particles. We use what? We use formula mass. Formula mass to go from moles to grams or grams to moles. Formula mass for calcium, 40.08. Formula mass for chlorine, 35.45, correct? But I'm going to have to do 2 different calculations here. The first one, I'm going to start with calcium. It's in grams. How do I get it out of grams and into moles? Grams on the bottom. 40.08 grams on the bottom, 1 mole on top, right? Okay? That gives me the moles of calcium, correct? Okay, good. Now, I'm going to do the same thing for chlorine. How do I get chlorine out of grams and into moles? Grams on the bottom. 35.45 grams on the bottom, 1 mole on top. Here's what we get. You get a lot more boxes to fill in, don't you? Are there any questions on what we've done so far? All we have done is taken both of our grams that we have been given and fruit fly. Did you get it?
No, I didn't get it.
If you get the chance, ladies and gentlemen, there's a bounty out on every fruit fly in my room. Kill it. Kill it. Okay. Any questions on what we've done here? Okay. When we write a chemical formula, Phoebe, give me an example of the formula for magnesium combining with chlorine.
MgCl2.
So for every one magnesium, there's how many chlorines? 2. Stephen, give me the formula for iron 3 fluoride. Iron 3 fluoride. Iron 3 fluoride.
Oh, FeF3.
FeF3. How many irons? How many fluorines for every one iron? 3. Those are ratios, right? For every one magnesium, there's 2 chlorines. Yes, sir. I'll have to go get you one. For every one magnesium, there's 2 chlorines. For every one iron, there's how many fluorines? 3. That is a ratio. Every chemical formula shows a ratio. Ow. All right. You can try. You're not going to win. Here you go. So, how do I take these numbers and make them into a ratio, ladies and gentlemen? Divide by what? No. If you divide these by 1 mole, they're not going to change. They're not going to change. They're going to stay the same. So, Phoebe, your formula was MgCl2, correct? MgCl2. So if you have 5 atoms of magnesium, how many atoms of chlorine do you have to have? 10. 2 times that, correct?
Yeah.
Correct? Okay. What if you have 30 atoms of fluorine? How many atoms of iron are you going to have? 10. By the way, what happens if you take 10 or 20 atoms divided by 10? Still a 2-to-1 ratio, right? What happens if we take 30 divided by 10? Still a 3-to-1 ratio. Find a ratio here, ladies and gentlemen. Divide by the smaller amount of moles. Divide both of them by the smaller amount of moles. Because what will that guarantee you to get for a number? 1. 1. You will get a 1. 0.29 divided by 0.299 is what? 1. And then this is going to be what compared to 1? Larger. 1 to 2. Now, it doesn't work out perfect. 1.98. That's pretty close to 2, isn't it? So what would the ratio of your compound be? 1 calcium to 2 chlorines. CaCl2. CaCl2. So we can use the mole to figure out the formula of a compound. As long as we know how much of each thing there is in the compound. Because again, just like we were talking about a minute ago, ladies and gentlemen, this is simply a ratio. 1 molecule of this is 2 atoms of this to 1 atom of this. 1 mole of these molecules is 2 moles of this to 2 moles of this. But again, we can even relate it back to mass. We can relate it back to mass. So what we're doing is we're using mass here, ladies and gentlemen, to get to our ratio. But the problem is mass ratios are ugly. This is 40.08 grams to 70.9. That's a terrible ratio, 40.08 to 70.9. But you know what is a nice, easy ratio? 1 to 2. And mole ratios always show up in nice, easy ratios. All right. Find the empirical formula of a compound that is composed of 30.7 grams of sodium, 69.4 grams of chromium, and 74.7 grams of oxygen. What kind of compound is it?
It's ionic.
It's an ionic compound. Why?
There's no atoms.
Hey, guess what? Because you have 3 elements, guess what? No, yes, very good. Thank you. I wasn't even thinking that, but yes, Stevie, absolutely correct. It's ternary. Okay, but what else? You got to do this 3 times.
The last two is
The last one, there were only 2 elements. You had to do it for each element. Now you got to do it for 3. So again, we need formula masses. But here's the good news. Formula masses are the numbers off of the periodic table because these are the elements that make it up. These we get right off of the periodic table. 22.99, 52.0, 16.00. We get them right off of our periodic table, ladies and gentlemen. 30.07 grams of sodium. 1 mole of sodium over 22.990 grams of sodium. Gives us 1.34 moles. 69.4 grams of chromium. 1 mole of chromium over 52.00 grams of chromium. Gives us 1.33. Hey, by the way, what do you notice about these numbers? They're similar. That's good. That's good. 74.7 grams of oxygen. 1 mole of oxygen over 16.00 grams of oxygen. What do we get? 4.67. What? That's not close to 1.33, is it? No. But these are now in moles.
divided by the small number.
Divided by the smallest amount there. Because it guarantees us to get something to 1. Guarantees us to get something to 1. And all mole ratios are whole number ratios.
2.5.
What's the matter? What's wrong?
What? I got 3.5.
What?
I use a 4.67 divided by 1.33. I got 3.5.
Really? Because I got 1 for the top, 1 for, and I got 3.5 for the bottom too?
Yeah.
Okay.
So
That's
times
fine.
2.
The kid's catching on, ladies and gentlemen. How do you get rid of a 0.5?
Times 2.
You multiply everything times 2. You multiply everything by 2. Sorry, sometimes it's not going to be 1 to 1 to 2. Sometimes it's going to be 2 to 2 to 7. It all depends on what the ratio is. It is possible that you could have 7 or 5 or 9 of something in your compound. That is possible. The only ones I will give you, ladies and gentlemen, are a 0.5, which you would multiply by 2. Possibly a 0.33, which you would multiply by 3. Or possibly 0.25 to multiply by. But we have to multiply every one of these. You remember that half trick that we did when balancing chemical equations? Where we put 3.5 in there to get it to balance, to get to an odd number with a diatomic? Then we had to go back and multiply everything by 2. Same idea here. Same idea here. We're going to take 1 times 2 to get 2. We're going to take 1 times 2 to get 2, and we're going to take 3.5 times 2 to get 7. So what is our formula? Na what? Na2. CrO. Okay. Now, name that compound. You did so well there, Josie. You were like, sodium something. Shenza's got the right idea.
Dichromic.
Phoebe, you're the one who told us earlier. Has to be what?
Sodium.
So you got to flip your periodic table over and find the Cr2O7 on the back. What's Cr2O7?
Dichromate.
Dichromate. Sodium dichromate, ladies and gentlemen. That is the name of this compound.
Sodium dichromate.
Sodium dichromate. Questions?
Pretty freaking
Oh.
Here's your chance, ladies and gentlemen. Questions if you got them. No? Zero? Zip? Zilch? So let's take a look at this next one. What's different about this next one? What's that?
It's a longer question.
No, it's about the same distance as the other one.
Percent.
There's percentages. Oh my God, what do we do with percentages? Huh?
That's what happened.
Why are we multiplying them by 100?
To get 38 point, or get the number by itself without the percentage.
To get the number by itself without the percentage. Okay, you are on the right track. Here's the nice part. When they give you percentages, ladies and gentlemen, guess what? You can pick any sample size you want. Any sample size at all. Because you're telling you what percentage of that sample is each one of these. You want to pick a 1 gram sample? Go ahead. You want to pick a 5 gram sample? Go ahead. I wouldn't right now. I would not miss this, but you're free to if you want. What is the best sample size to pick when you have to pick a sample size, ladies and gentlemen? What? Pick 100 grams. Because what happens to those percentages when you pick 100 grams? The percent goes away and it becomes grams. 38.13 grams, 16.80 grams, and 44.7 grams. If you pick a 100 gram sample, ladies and gentlemen, if you pick a 100 gram sample, all of the percentages simply become grams. So this becomes 3.18 or 38.13 grams, 16.80 grams, 47.4 grams. And now guess what? It's just like the last problem you did. Just like the last problem you did. Your percents have become grams. Your grams can become moles. By doing what we just did. By converting from grams to moles using formula mass. 1 mole of manganese over 54.9894 grams of manganese. Sorry, might have left it that way. 1 mole of carbon over 12.01 grams of carbon. 1 mole of oxygen, 16.00 grams of oxygen. Get 2 moles. Now what do we do when we get to these moles, ladies and gentlemen? What's the smallest number up there?
0.694.
Divide them all by 0.0694.
124.
I agree. First one's 1. What's the second one?
2.
What's the third one?
4.
Should come out with a whole number ratio, ladies and gentlemen. Now again, I am not guaranteeing you that your numbers are going to come out to be exactly 2. 1.98, 1.97, 2.01, 2.02, but that's close enough that we can round it. Can we round 2.5? No. Can we round 2.25?
No.
Can we round 2.33?
No.
But we can round 1.95. We can round 2.05. We can round 3.1. Okay, we can round numbers here if they're close to a whole number. So what would our formula be here? Formula. Mn what?
C2O4.
Mn C2O4. Okay, gotta be a diatomic in there, correct? No. What did I just say? Oh my gosh. Gotta be a what in there, not a diatomic, sorry. Gotta be a polyatomic ion. 3 elements here, correct? So what is it, Josie?
Oxalate?
Manganese oxalate. Manganese oxalate, ladies and gentlemen. Questions? Tomorrow, bring your packets. You're going to have lots of time to practice, ladies and gentlemen. And by the way, this will be on the quiz on Friday.
Are you over the time?
Yeah, I don't know. I just been doing it for an hour.
I'm so sorry. Okay, I tried. Let me get.